Hello, welcome. We are in chapters 8, 9, and 10, and in this video we're going to be going through lesson 8.2. We're continuing to talk about solving systems of equations, and in this video we're just going to cover a new method, and that method is called elimination. Now, if you remember from solving by substitution, when we solve a system, our answer should be a point. So we should be getting an x and a y value when we're solving. Now, this method elimination, when we think about the word to eliminate is to get rid of, to cancel out, or to cross out. So when we're eliminating, our goal is to get rid of one of the variables. So to do this, we do want our x's and our y's to be lined up. That will be helpful for elimination. So you'll see here most of these equations have the x's and the y's lined up, meaning they're kind of in the same spot in both equations. The first thing that we're going to check for to solve a system by elimination is we need the same number but opposite signs in front of one variable. So I'm going to say in front of x or y. What I mean by same number is like here, the x's both have a 5 in front. So we want them to have the same number. However, we do want them to be opposite, meaning we want one positive and one negative. If we don't have that, we're going to talk about how we can create that in our equation. So we need the same number. They do need to be opposite signs. Once we have that, then we're going to add the equations together. So we're going to go through just a handful of situations with elimination. And again, we're looking for same number, opposite signs in front of x or y. When I take a look at number 1, I did point out we do have the same number in front of x. So we have a 5 and a 5, and they are opposite. One is positive and one is negative. As long as we have that, then we're going to go ahead and add the equations together. So I'm going to go ahead and add. Now, what happens when we add 5x plus negative 5x is that's 0. Those will go away, or in other words, they're eliminated. So we're eliminating one of our variables. We can add 4y plus negative 2y. I would think of this as a negative 2, so 4 plus negative 2 is 2y. And then we also have to add over here negative 7 plus 1. Negative 7 plus 1 is negative 6. Now, we have a pretty simple equation that we're solving here, so we could divide by 2 on both sides, which makes y negative 3. Now, again, this is only part of my answer. This is just the y value, so when I'm writing my final answer, negative 3 is the y value, but I don't know the x value. However, once we know one of our values, kind of like in our last method, substitution, we can take negative 3 and we could plug it in for y. So I could either plug it into this equation for y, or I could plug it into this equation for y. It does not matter which one you choose, so as long as you put one of them, you can solve for x. I'm going to go ahead and just use the top equation. So this is going to be my second step. So 5x plus 4, again, y is negative 3. So instead of writing y, I'm plugging in negative 3, and then we should be able to solve. 4 times negative 3 is negative 12, so I'm going to turn that into minus 12. To undo subtracting, I could go ahead and add 12, and then 5x will equal 5. Dividing by 5, our x value will be 1. So that makes my answer the point 1, negative 3. All right, we'll try that process again. Again, to start, I'm looking for the same number in front of x or y. Now, I don't have the same number in front of x, but I do have the same number in front of y. However, these are not opposite. They're both positive. And that gives us a little bit of a problem. So what I'm going to do is I can just make one of them negative. However, if I make this negative, I have to change the whole equation. I can't just change one part. That means I'm going to have to switch the sign of this, and I'm going to also switch the sign of this. So if they're not opposite, I can just go through and I can switch the signs of everything in that equation and make all of those things opposite. Now I have same number, opposite signs in front of the y's, so I can go ahead and add my equations together. 2x plus 4x is 6x. If I add negative 2 plus 2, negative 2 plus 2 is 0, so my y's are eliminated, they go away. And then negative 6 plus negative 12, negative 6 plus negative 12 is negative 18. We'll divide by 6, so x will be negative 3. Again, that's just my first part, so I can take negative 3 and I can plug it in for x. Again, we could plug it into this equation or this equation. You could use the original equation or the opposite when we made them negative, that's fine. I'll go ahead and do the bottom equation though. So I'll go ahead and plug negative 3 in for x. So I'll do 4 times negative 3 plus 2y equals negative 12. 4 times negative 3 is negative 12. To move that negative 12, I would add 12. Now, we do want to be careful here. Negative 12 plus 12 is 0. It is possible you might get 0. We still have a variable here, so it's not like we have no solutions. 0 is a possible solution that we might get. So if I wanted to solve this, we just have 2 times y, so I could still divide by 2, and we know 0 divided by 2 is just 0. So that just means that my y value is 0. Here, when they go away, they're really adding to 0. So my answer would be the point negative 3, 0. Now, if we take a look at number 3, what I notice is I don't have the same number in front of the x's, and I don't have the same number in front of the y's. So what we're going to have to do is we're going to have to create the same number. To create the same number, we're going to multiply. So what I want to think about is what could I turn both 8 and 3 into? Or what could I turn both 3 and 2 into? You could do either one. You could get 8 and 3 to be the same. 24 would be a good number for that. Or you could get 3 and 2 to be the same. 6 would be a good number for that. I'm going to go ahead and get my y's to be the same, just because those are smaller numbers. So to turn the top into 6, I'm going to multiply by 2. So if I wanted to turn this into a 6, I would multiply by 2. I can't just multiply this, though. I'd have to multiply the whole equation. On the bottom, to turn 2y into 6, I'd want to multiply by 3. So I'd want to multiply this by 3. Again, I can't just multiply this, though. I'd have to multiply the whole equation. However, one thing I notice is right now these are both positive, and I do want them to be opposite. I do want one to be negative. So I'm going to choose just one of these to be negative, and I'm going to multiply by a negative instead. That way they're opposite. Again, you could choose either one as long as you're making one of them negative. So I'll go ahead and multiply. I'm multiplying this whole equation by negative 2. That's going to give me negative 16x. Negative 2 times 3y is negative 6y, and negative 2 times 13 is negative 26. Bottom equation, I'm multiplying by 3. 3 times x is 9x, 3 times 2y is 6y, and 3 times 11 is 33. Now I can check and see I have the same number in front of y's and they're opposite. One is positive and one is negative. So you might just have to pick numbers that help you turn those values into the same number. Once we have same number, opposite signs, we can go ahead and add our equations together. Negative 16 plus 9 is negative 7x. Negative 6y plus 6y is 0, so those are eliminated. And negative 26 plus 33 is 7. If we divide by negative 7, that will give me an x value of negative 1. Again, that's just part of my answer. So negative 1 is the x value. However, we do want to find y. So step 2 is I'm going to take negative 1. and I'll plug it in for x. Again, you could either use your top equation or your bottom equation. It doesn't matter which one, as long as you pick one. I'll go ahead and use my bottom equation. So I'll do 3 instead of x. I'll plug in -1. 3 times -1 is -3. To move that -3, we could add 3. 11 plus 3 is 14, and then if we divide by 2, y will be 7. So my answer would be -1, 7. All right, we'll take a look at number 4. Again, if you've kind of tuned out or you figured you understand it now after seeing 3 examples, I would encourage you to watch this one. This one is a little bit different than the other one, so we're going to see kind of a special case here. Now, if I look, x's do not have the same number, y's do not have the same number. So I'm going to want to make the same number. I could change either one, so I could change my x's to be the same or my y's to be the same. For x's, I could just turn this into 6 by multiplying by 2. Or for my y, I could just turn this into 4 by multiplying by 2. So I'm going to go ahead and multiply that bottom equation by 2. Let's just say we're getting our x's to be the same. So I'll multiply by 2 to get those to be the same. Again, though, they are both positive, and because they're both positive, I'm going to make this a -2. That way they're also opposite when we get them to be the same. So my top equation, I'm actually not changing at all, so that's going to stay. And then my bottom equation, I'll multiply by -2. -2 times 3x is -6x. -2 times 2y is -4y. And -2 times 7 is -14. I now see we have same number opposite signs in front of my x's. I also see that we have that in front of the y's. So when we add this together, we're going to kind of see what happens. -6, or 6 plus -6 is 0, so those will be eliminated. And 4 plus -4 is also 0. So really what we get is we just get 0. Both of my variables are actually eliminated. If we add 8 plus -14, that's -6. Now, here's what happened. My variables went away, and we're left with 0 equals -6. That doesn't mean 0 is my answer or -6. This is not a true statement. 0 does not equal -6. What that means is there's actually no numbers that we could plug in for x or y that would make this system true. That means this actually has no solutions. If your variables both go away, if there's no longer an x or a y, we cannot solve that, and we would say that that's no solutions. The only other thing that could happen is these both could be the same number if you get like 0 equals 0. If that is true, then we would actually put infinite solutions or all real numbers. So if it's a true statement, you would have infinite solutions, but if it's a false statement like this, that means we have no solutions.